Okay, by now you should have done well on a quiz on exponents, and we're going to continue on section 1.6. The only difference in section 1.6 and what we've done so far is now we're going to focus on our exponents being rational numbers. That is, our exponents are fractions. None of the rules of exponents change. So when we started out this unit on exponents, we talked about rules. What happens when we multiply a number, same number raised to two different exponents? We add the exponents. And then what happens when we have something raised to an exponent and then raised to an exponent again? We multiply those exponents, okay? So those are rules that we're doing. Distributing, when we have a product raised to an exponent, that's the same as each of those individual elements of the product raised to that exponent. So, for example, let's look at a few. 2 to the 1/2 times 2 to the 3/2. I add those exponents. So this is 2 to the 1/2 plus 3/2. 1/2 plus 3/2 is 4/2. So this is 2 to the 4/2. Another way of writing 4/2 is 2. This is 2 squared, and that is 4. Okay, same things we've done, it's just that the exponents are going to be rational expressions here. 2 squared to the 1/2. You multiply these exponents. So that's 2 times 1/2. And so 2 times 1/2 is 2 over 2, or 1. This is just 2 to the 1, which is 2. Now, if you look at the next one, a couple ways they're going to do it. This is 6 cubed, because 2 times 3. But if I distribute this exponent, I get this is 2 cubed times 3 cubed. That is 8 times 27. And that is 160 plus 56, which is 216. Okay, so it's just the same things we've been doing so far, but the exponents tend to be rational numbers. So similarly, same things with negative exponents. Okay, if I have a negative exponent, wherever I find it, the numerator, I can make it positive by moving that expression to the denominator. When I have a to the m divided by a to the m, same thing, a to the m minus n. When I have a quotient, a over b to the m, I can distribute that across everything. So again, nothing's changing. The rules are the same. It's just that we're dealing with rational exponents. So in this case, my goal is to leave no negative exponents. So another way of writing this is 1 over 7 to the 2/5. Okay. Now, if you have been told to leave this in radical form, that's fine for exponent form. This will be 1 over the 5th root of 49, or the 5th root of 7 squared. Either way for this one. Now, if I look at this one, 2 to the 3/2 divided by 2 to the 1/2. According to my rules of exponents, this is 2 to the 3/2 minus 1/2. 3/2 minus 1/2 is 2/2, so this is 2 to the 2/2. 2/2 is 1. This is simply 2. 8 over 27 to the 1/3. This is 8 to the 1/3 divided by 27 to the 1/3. Raising something to the 1/3 is the cube root. Cube root of 8 is 2. So this is 2 over cube root of 27 is 3. This answer is 2/3. Okay? So again, basic rules we've been doing is just we're switching gears and having fractions or rational expressions as our exponents. Okay? So look at this one, 12 to the 1/8 times 12 to the 5/6. What do we do with the exponents here? We add them. So this is 12 to the 1/8 plus 5/6. Okay? How do I add 1/8 and 5/6? So to add 1/8 and 5/6, just adding fractions. I'm going to have to multiply this by 3 over 3 plus 5/6. I'm going to have to multiply that by 4 over 4. My common denominator is going to be 24. So this is going to be 12 to the 3/24 plus, pardon me, 3/24 plus 20/24. When I add those together, I get 12 to the 23/24 power. Okay, I know that may look ugly, but that's the right answer. Okay, so it's when you're adding the fractions, you have to keep in mind that you may have to find common denominators in order to make this happen. So answer here, 12 to the 23/24 power. Look at the next one. Simplify 5 to the 1/3 times 7 to the 1/4, all of that to the -3 power. And as you can tell, I don't want to leave negative exponents. So I've got choices. I can take care of the negative exponent right away. That is, move everything in the parentheses to the denominator. Or I could just distribute and take care of my exponents at the end. Really doesn't matter how I do this. So in this case, let's just go ahead and distribute the exponent. So this will be 5 to the 1/3, and then I'm going to raise that to the -3 times 7 to the 1/4. All of that to the -3 power. You multiply exponents. This is 5 to the -1 times 7 to the -3/4. Okay, taking care of those exponents, this is 1 over 5 to the 1 times 7 to the 3/4. So I have my answer. I have everything in exponents, positive exponents. Okay, let's look at the next one. 56 to the 1/3 divided by 7 to the 1/3. Okay, if I want to simplify this, first thing you want to recognize here is there any simplification in the parentheses? Okay, I look at this immediately and I know that 56 is 8 times 7. So if I look at this, this is 56 over 7 to the 1/3. What's 56 over 7? That's 8. This is 8 to the 1/3. What's the cube root of 8? Cube root of 8 is 2. Okay? So in this one, if you look at it, what we started with here, it was all positive exponents. Okay, you would have been tempted to say, I can't take the cube root of 7, can't take the cube root of 56 and get integer values back. But 56 over 7 is 8, and I can take the cube root of 8. So just another way of looking at that. So let's look at this. We look at radicals as well. So 96, the fifth root of 96 divided by the fifth root of 3. Now, one of the keys of simplifying this is to say, okay, is there a relationship between 96 and 3? Immediately, I know that 96 is divisible by 3. Now, you've got choices of how to do this. You could just simplify the radical. So we're going to work this two different ways. Let's simplify the radical on the left, or let's just start out with 96 divided by 3. You'll see that on the right. So if I look at that, 96, when I am taking the fifth root, I want to organize something to the power of 5. I know that 96 is divisible by 2, so that gives me 48. That's divisible by 2. 24 is divisible by 2. 12 is divisible by 2. And 6 is divisible by 2. Now, taking the fifth root, I count 1, 2, 3, 4, 5. So this is 2 to the fifth times 3. So I can write this as the fifth root of 2 to the fifth times 3 over the fifth root of 3. Fifth root of 2 to the fifth is 2. So this is 2 times the fifth root of 3 divided by the fifth root of 3. The fifth root of 3 divided by the fifth root of 3 is 1. This answer is 2. Now, another way of writing this, I could have written this as, okay, this is the fifth root of 96 over 3. 96 divided by 3 is 32. This is the fifth root of 32, which is 2. Same answer. Another way I could have looked at this as this is 96 to the 1/5 over 3 to the 1/5, which is just 96 over 3 to the 1/5. 96 over 3 is 32. This is 32 to the 1/5. That's the fifth root of 32. So not to confuse you, but just to recognize if you are obeying the properties of radicals and exponents, there are multiple ways to get to the right answer on pretty much any of these problems. Simplify 27 to the 2/3 raised to the 1/2 power. Now in this case, what do I do with exponents? I will multiply them. So this is 27 to the 2/3 times 1/2. So this is 27 to the 2/6 power. You know how to simplify and reduce fractions. This is 27. 2/6 is 1/3. That's the cube root of 27. That answer is 3. (64 to the 5/9 times 64 to the 2/9 divided by 4 to the 3/4. Okay, so let's look at this and see what we can do. On the top of this fraction, this will be 64 to the 5/9 plus 2/9. I can add those exponents, divided by 4 to the 3/4. And in doing that, I get 64 to the 7/9 divided by 4 to the 3/4. Okay? So, how do I look at this? Well, I don't have everything raised to the same power, but what I can look at is I know that there's a relationship between 64 and 4. 64 is 4 cubed. 4 times 4 times 4 is 64. So let me go ahead and convert that 64 to a 4 cubed and see if that helps me. So this is 4 cubed to the 7/9 over 4 to the 3/4. So I'm going to, on the top of this fraction, this is 4 to the, when I multiply those, I get 21 over 9 over 4 to the 3/4. Okay, so now what I do is when I see a fraction like this, I need to subtract these exponents. So this is 4 to the 21 over 9 minus 3/4. And in order to do this, I need a common denominator. So just so that you remember, 21 over 9, looks like my common denominator is going to be 36. I'm going to multiply that by 4 over 4 minus 3/4, and I'm going to multiply that by 9 over 9. And in doing so, this is going to be, what, 84. So this is 84 over 36 minus 27 over 36, which gives me a 7, so 57 over 36, I think. So let me double check that. Yeah, so in this case, I'm going to get 4 raised to the 57 over 36 power. That's my final answer. So the biggest thing there was the arithmetic with the fractions, okay? The rules of exponents are all the same. I started out here, add the 5/9 and the 2/9, and I get 7/9. So 64 to the 7/9 over 4 to the 3/4. Once I do that, in order to simplify everything in terms of 4, I write 64 as 4 cubed. So that's 4 to the 21 over 9 divided by 4 to the 3/4. 21 over 9 minus 3/4. That is 84 over 36 minus 27. And that gives me 57 over 36, which is my final answer. And one last one here. So let's look at this. 7 cubed over 4 cubed, all of that to the negative 1/3 power. Okay? A couple ways of doing this. One, I can take care of that negative exponent right away by writing this as 4 cubed over 7 cubed, raising all of that to the 1/3. So all I did was flip the numerator and the denominator, and now I've got a positive exponent. Now I just multiply exponents. This is 4 to the 3 times 1/3 over 7 to the 3 times 1/3. This is 4 over 7. Okay? So again, just following the rules of exponents, something that looks complicated like this original problem simplifies down pretty easily. Okay? That should be it for the section, and you've got homework in 1.6.